CompTIA A+, 220, 1101, and 1102. Best Practice Methodology. Best Practice Methodology, Steps 1 through 6. Step 1, identify the problem. Step 2, establish a theory of probable cause. Step 3, test the theory to determine the cause. Step 4, establish a plan of action to resolve the problem and implement the solution. Step 5, verify full system functionality and, if applicable, implement preventative measures. Step 6, document the findings and actions and outcomes. Step 1, identify the problem. The troubleshooting process starts by identifying the problem. Identifying the problem means establishing the consequence or impact of the issue and listing symptoms. The consequence can be used to prioritize each support case within the overall process of problem management. Gather the information from the user. The first report of a problem will typically come from a user or another technician, and this person will be one of the best sources of information if you can ask the right questions. Before you begin examining settings in Windows or taking the PC apart, spend some time gathering information from the user about the problem. Ensure you ask the user to describe all the circumstances and symptoms. Some good questions to ask include: what are the exact error messages appearing on the screen or coming from the speaker? Is anyone else experiencing the same problem? How long has the problem been occurring? What changes have been made recently to the system? Were these changes initiated by you or via another support request? The latest change to a system is very often the cause of the problem. If something worked previously, then experiencing mechanical failures is likely that the problem has arisen because of some user-initiated change or some environmental or infrastructure change. If something has ever worked, a different approach is required. Has anything been tried to solve the problem? Perform backups. Consider the importance of data stored on the local computer when you open a support case. Check when a backup was last made. If a backup has not been made, perform one before changing the system configuration if possible. Step 2. Establish a theory of probable cause. Conduct research. You cannot always rely on the user to describe the problem accurately or comprehensively. You may need to use research techniques to identify or clarify symptoms and possible causes. One of the most useful troubleshooting skills is being able to perform research to find information quickly. Learn to use web and database search tools so that you can locate information that is relevant and useful. Identify different knowledge sources available to you. When you research a problem, be aware of both internal documentation and information and external support resources, such as vendor support or forums. Make a physical inspection. Look and listen. You may be able to see or hear a fault. If the symptoms of the problem are no longer apparent, a basic technique is to reproduce the problem. That is, repeat the exact circumstances that produced the failure or error. Sometimes problems are intermittent, though, which means they cannot be repeated reliably. Issues that are transitory or difficult to reproduce are often the hardest to troubleshoot. Check the system's documentation, installation, and event logs, and diagnostic tools for useful information. Consult other technicians who might have worked on the system recently or might be working now on some related issue. Consider that environmental or infrastructure changes might have been instigated by a different group within the company. Perhaps you are responsible for application support and the network infrastructure group has made some changes without issuing proper notice. Consult vendor documentation and use web search and forum resources to see if the issue is well known and has an existing fix. Step 3. Test theory to determine cause. Question the obvious. As you identify symptoms and diagnose causes, take care not to overlook the obvious. Sometimes seemingly intraceable problems are caused by the simplest things. Diagnosis requires both attention to detail and a willingness to be systematic. One way to consider a computer's problem systematically is to step through what should happen, either by performing the steps yourself or by observing the user. Hopefully, this will identify the exact point at which there is a failure or error. If this approach does not work, break the troubleshooting process into compartments or categories, such as power, hardware components, drivers, firmware, software, network, and user actions. If you can isolate your investigation to a particular subsystem by eliminating non-causes, you can troubleshoot the problem more quickly. For example, when troubleshooting a PC, you might work as follows. Decide whether the problem is a hardware or software related issue. Decide which hardware subsystem has been affected. Decide whether the problem is in the disk unit or connectors and cabling. Then, test your theory. A basic technique when troubleshooting a cable, connector, or a device is to have a known good duplicate on hand. This is another copy of the same cable or device that you know works that you can use to test by substitution. Step 4. Establish a plan of action to resolve the problem and implement the solution. When you have a reliable theory of probable cause, you then need to determine the next steps to solve the problem. Troubleshooting is not just a diagnostics process. Devising and implementing a plan to solve the problem requires effective decision making. Sometimes there is no simple solution. There may be several solutions, and which is best might not be obvious. An apparent solution might solve the symptoms of the problem, but not the cause. A solution might be impractical or too costly. Finally, a solution might be the cause of further problems, which could be even worse than the original problem. There are typically three generic approaches to resolving an IT problem. Repair. You need to determine whether the cost of the repair makes this the best option. Replace. Often more expensive and may be time-consuming if parts are not available. There may also be an opportunity to upgrade the parts or software. Workaround. Not all problems are critical. If neither repair nor replacement is cost-effective, it may be best either to find a workaround or just to document the issue and move on. If a part or system is under warranty, you can return the broken part for a replacement. To do this, you normally need to obtain a Return Materials Authorization, RMA, ticket from the vendor. Establish a plan of action. When you determine the best solution, you must devise a plan of action to put the solution in place. You have to assess the resources, time, and costs required. Another consideration is potential impact on the rest of the system that your plan of action may have. A typical example is applying software patch, which might fix a given problem but cause other programs to not work. Implement the solution. When you make a change to a system as part of implementing a solution, test after each change. If the change does not fix the program, reverse it, and then try something else. If you make a series of changes without recording what you have done, you could find yourself in a tricky position. Step 5. Verify full system functionality. When you apply a solution, test that it fixes the reported problem and that the system as a whole continues to function normally. Tests can involve any of the following. Try to use a component or performing the activity that prompted the problem report. Inspecting a component to see whether it is properly collected or damaged, or whether any status or indicator lights show a problem. Disabling or uninstalling the component. Consulting logs and software tools to confirm a component is configured properly. Updating software or device driver. Before you can consider a problem closed, you should both be satisfied in your own mind that you have resolved it and get the customer's acceptance that it has been fixed. Restate what the problem was and how it was resolved, and then confirm with the customer that the incident log can be closed. Implement preventative measures. To fully solve a problem, you should implement preventative measures. This means eliminating any factors that could cause the problem to reoccur. For example, if the power cable on a PC blows a fuse, you should not only replace the fuse but also check to see if there are any power problems in the building that may have caused the fuse to blow in the first place. If a computer is infected with a virus, ensure that the antivirus software is updating itself regularly. and users are trained to avoid malware risks. Step 6. Document findings, actions, and outcomes. Most troubleshooting takes place within the context of a ticket system. This shows who is responsible for any particular problem and what its status is. This gives you the opportunity to add a complete description of the problem and its solutions, findings, actions, and outcomes. This is very useful for troubleshooting, as problems fitting into the same category can be reviewed to see if the same solution applies. Troubleshooting steps can be gathered into a knowledge base or frequently asked questions (FAQ) of support articles. It also helps to analyze IT infrastructure by gathering statistics on what type of problems occur and how frequently. The other value of a log is that it demonstrates what the support department is doing to help business. This is particularly important for third-party support companies who need to provide the value achieved in service contracts. When you complete a problem log, remember that people other than you may come to rely on it. Also, logs may be presented to customers as proof of troubleshooting activity. Write clearly and concisely. Check for spelling and grammar errors.